right, so today we are doing the virtual production demonstration. This is Daryl and mine's personal stress moment for the day. Anyone here ever worked in motion capture? Done any motion capture work? A few of you out there. Has it always gone perfectly? Is it like the smoothest thing in the possible world? Yeah, you got a bunch of people in the back like, whoa. It's like, so what we are about to attempt, I like to frame this correctly, is we are basically taking over the booth next to us where we have motion capture studio essentially running. So we've run cables over to their booth, so we have access to all the data that's streaming off their mocap system. And we're going to be using that inside of Motion Builder and Maya on this side. We'll also, at the end of the demonstration, be looking at Tank, which is the newly released asset management system, which we're going to be showing you how you can manage the assets that come through a process like this. So you're going to want to kind of check out both of them, and I'll explain kind of how they all tie together. But what this demonstration is basically people from each of these companies came together Sunday, met each other for the first time, and we've built a production pipeline here on the booth. So we're not smoke and mirroring it. This is real data that's going to be moving around between them. We're going to show it to you with cameras and the whole 9 yards. And we're basically going to cross our fingers and make sure we don't have like the data gods come down on us and like break our connection or any of those kinds of things that can happen with mocap. So with that, we're going to get started. And first off, I'm going to set the stage on virtual production. How many people are familiar with what virtual production is? It's been a bit of the buzz going around SIGGRAPH this year. We've been talking about virtual production now for about 4 years at SIGGRAPH. And what virtual production essentially is an answer to a problem that's slowly been building over the last couple decades. Way back in the day when a director shot a movie, most of what he did was in camera. He could sit down, look through the eyepiece of the camera, and see what the shot was going to be and make creative choices based on it. He's like, oh, this is going to look horrible. No, we got to move here, move the actor there, do this, change the light. Over the last 20 or 30 years, it's become more and more digital. So the director is looking through an eyepiece at an actor that doesn't represent the actual character that's going to be in the movie, because that's going to be a CG character. The environment doesn't exist yet, so it's just a green screen in the background. And the director is supposed to try and make creative decisions based on that. It's kind of like I have a picture in my mind, and I'm going to describe it to you, and I want you to draw it for me 3 months from now. It's like, it's a very awkward, and then you'll come back with a picture that has nothing to do with what I thought about. And I'm going to give you change orders, and we're going to do it again and again. And it's a very expensive, time-consuming, and often not, it really destroys the creative vision. So virtual production allows a director to actually look through an eyepiece of a camera, control what feels like a real camera, but that camera is a look into the virtual world that will be his movie someday in the future. And so we're going to show you exactly that with people in your typical black suits with ping pong ball kind of experience driving what would be the final movie. So with this, I'm going to pass it over to Daryl, who's going to start us off and kind of set the stage for the actual content in this presentation. So Daryl, take it away.
So actually, let's go ahead and start off by playing back a QuickTime movie of a short that we're going to be using the assets from to do this virtual production with today. And this is a movie that was generated by Hatch Studios in Toronto for us. And if we could get some audio on this on PC too, that would be good. It's worth mentioning that Hatch actually did this production in Max, and we brought the files over into Maya through FBX, which is an amazing underlying technology between all of our applications that really gives us an elegant way of exchanging data. Yeah, I'd like to thank Hatch for all the hard work they put into that, and then also providing us with the assets that we can use this year in our booth to kind of tell you this virtual production story. And we're going to be using Maya's Entertainment Creation Suite to do that. The Entertainment Creation Suite comes with Maya, Mudbox, and Motion Builder, and that really gives us a nice set of tools that we can use to basically bring this character to life using actors on the stage, the NaturalPoint stage. So the first thing that we're going to do is just hop into Maya really quickly, because that really is sort of the hero application that the Entertainment Creation Suite's based around. This is really where the majority of the work happens, but certain tasks are going to be more conducive to something like Mudbox for sculpting the geometry, or if we're trying to deal with motion capture data coming in, then we'd want to go and jump into Motion Builder. So Maya gives us kind of the hub that we're going to base all of that production around, and we'll branch off onto those other applications where the tasks are going to be a little bit more elegantly handled by them. So if we just kind of look at our character here, you can see that we've got a pretty decent environment, but this character lacks a lot of detail. So the color map has already been loaded onto it, but there's really no subtle detail to the overall kind of texture of his body. So we want to add a little bit more detail to that, and the best place to do that type of work is going to be inside of Mudbox. When we want to get data from Maya into either of the applications, actually any of the entertainment creation applications inside of Maya, we use these single-click workflows. All we have to do is select the piece of geometry that we want to send somewhere, and just go to the send to command. So you can see that we can send to Max, Softimage, Motion Builder, and Mudbox. We have several options, whether we want to start as a new scene, update the current geometry that's already in an existing scene, or maybe just add something to an existing scene without actually relaunching it. So we've already got the character loaded up because I've started some of the work in Mudbox. So we would just simply do an update current scene. Then if we jump over into Mudbox, you can see our character loads in. Now, these products all look very similar, and they actually are all laid out in Qt in the Entertainment Creation Suite, so it has a very consistent feel when you're working inside of the suite. Inside of Mudbox, what we want to do is we want to start adding subtle detail to this character. We can do that both on color and on sculpting. So it works in a similar manner to Photoshop in the sense that you have a panel that sits on the right-hand side that allows you to build up either your sculpt layers or your paint layers in a very kind of Photoshop-y way. They have things like channel operators if you're doing the paint layer. So again, it feels consistent to the types of things that you've done before. It's not an abstract feeling painting program. For this character, we want to start adding some more sculpted detail to it. So we'll jump over to our sculpt layers, and I've got a layer already kind of set up here, this layer 4 that's been subdivided several times. So if you remember when I touched that piece of geometry inside of Maya, it was a very low polygon piece of geometry. We've already gone ahead and subdivided this a lot of times so that we can basically display a more refined version of this character. So he's going to have a very high poly count when we go ahead and we start sculpting on him, because we've gone up to level 4, which you can see here. So the first thing that we want to do is just start looking at a couple of the brushes that we have. So we have lots of different sculpting brushes. They're all going to behave slightly differently. The type of task that you would do with that brush will be explained to you if you just let your cursor sit on top of it. Next to the brushes, we have another set of windows that allows us to modify the way that brush is going to work. So is it going to have a stamp on the end of the brush that's going to get dropped down every so often as you move that brush across the surface? Stencils are basically rub through. So if I wanted to sculpt this character with a stencil, maybe rub through something, as I start to use this sculpt brush, actually let's turn off that smooth stroke on that brush really quickly. Double click on that guy and turn off smooth stroke. We don't want to use that either. Steady stroke is a really cool technology. We'll look at that in just a second, but you can see that I can use that kind of stencil to start rubbing through my character. And notice the speed at which that works. Because these brushes are so fast and so fluid feeling, it really is a great, easy to use product. And you can download this as a trial. Everyone should download this and try it out, because it's one of those immediately accessible pieces of technology that we have at Autodesk. So let's go ahead and just jump up to another layer here. We'll make another sculpt layer, and we're going to look at a brush that's a little bit more advanced than just this simple brush that we use to rub that on. We'll turn off that stencil. Actually, let's turn off the wireframe of that guy, and I want to dial that back a little bit. That's a little harsh. So you can see I have the ability to adjust that sculpt layer. I'm going to go up here and sculpt on top of that. We want to add a little bit of age to this character. We want to make him have a little bit of weight that's been put on him. And we're going to use another brush to do that. And this time we're going to change the stamp on this brush. And we're going to use something that's kind of advanced for the stamp. Instead of just using the luminosity range of something to kind of adjust how much those vertices are going to get moved, we're actually going to use a vector displacement map on our stamp. So this gives it the ability to actually push those vertices basically around and kind of pinch them, move them, shift them, not just push them off based on the normal of the object. So I'll grab one that's kind of cool here. Let's make sure we hover on it and get the right one. We'll get this one called Fold. I'll turn that steady stroke back on. We'll double click on this brush. What steady stroke does is it allows me to, it gives me a little arrow that's going to follow, and that little arrow basically takes the noise out of my wrist. So it just kind of smooths out your stroke and gives you a nice way of doing that. Notice that we have mirroring turned on. There's a little dot floating on the other side of the character here. And we're just going to simply push down on this guy and pull across. And you can see that as I do that, we're basically sculpting this character and getting an undercut at the same time. So you can see how it's not just pushing on the normal those, it's actually pinching and pulling that. And with that simple brush, we're able to add in really, really cool detail. Maybe I'd come up here to his neck and I want to start adding in some edges or some ripples in his neck. So we can just go over here, float on top of this. Let's find the edge brush. We'll grab a wrinkle brush. So with the wrinkle one, you can see as I start to do that how it pinches and pulls as it moves across. So these vector displacement maps are really, really cool. And again, it's non-destructive. It's all based on a layer system. If I don't want to display it or I want to dial back the amount that I've added in there, I can just simply adjust these layers. So let's just go ahead and turn on my final painted layer here. It's going to be a little stepped on where I painted across this texture here on his chest, but you get a sense of the type of detail work that we can get very, very quickly using these awesome brushes that Mudbox has. So let's talk about painting color really quickly. I'll jump over to my paint layers for color. We'll just grab a brush. And there's a couple of things that you can do. Again, we could also lay down a stencil and start rubbing through. So I might grab something like this and start to paint a little bit of color based on that stencil. You could use a texture map in there. You can go out to an image browser right up here and load in any textures that you want to clone off of or stencil off of. So it's a very fast, easy to work with environment. One of the brushes that I really like, and I'll show it to you very, very quickly, is this brush. It's called a dry brush. What the dry brush does is it allows you to paint, if you look at the little icon right here, it allows you to basically paint on the high areas of the character or the low areas of the character if you hold the control key. Any of the brushes, if you hit the control key, you get the inverse operation. So if you're sculpting and you're pulling out, you hit the control key, you start pushing in. If you're using something like a dry brush, if you are painting on the edges or the tops of the surface, if you hit the control key, you start painting in the cracks. Same thing for things like the hue, the dodge or the burn or the contrast. It's all based on using simple hotkeys to sort of modify the way that works. So if I start loosely painting on this, you can see that I'm just kind of grabbing certain areas of that as I scrub through this. It's not just painting on the whole object. It's just really now grabbing those top edges. You'll see it even better if I do it on something like these bumps. So as I lightly rub on this, you see it's only really painting on those bumps. And again, if I hold my control key down here, you'll see that it's going to paint in the cracks as I start to rub that in. So really very easy to use tools. So with that done, basically what we want to do is we want to capture all this sculpted detail that we've done in the form of a texture map that the rendering engine can then use to replicate the look that we have inside of Mudbox. If I brought this character back into Maya and tried to move it around, it's not going to behave very good because it's 4 million polygons now, and trying to move a 4 million polygon skin character is really not a great idea. So what we can do is we can extract this information in the form of, again, a vector displacement map and use that at render time to push and pull those vertices to get to the look of this character. And the extraction process is really easy to set up inside of Mudbox. All you have to do is go in here and say, we'll create a new operator on this guy. So we'll do something like a vector displacement map. You can see that it's going to grab the level 4, which is what we were painting on. That's where all that high fidelity detail is. And we want to push that into level 0, that original low-res mesh that came out of Maya. And it's going to generate a map that looks something like this. It's going to be a floating point map that's got all these strange looking colors. And that's what the renderer uses to get to that end result. Now, to make this out a 4K map like I used in my final scene, it takes a little bit of time. So I just wanted to explain it, but we're not actually going to execute it. So with that done, you can send this information back into Maya in a couple different ways. Again, using the single-click operators where you can say, send to Maya, do I want to update the scene, update just the textures, send the base mesh back across. So there's several different options on how to get that information back into Maya. Now for demo's sake, we've already saved out the shader with all the work set up. So we'll just jump back into Maya and take a look at that really quickly. So what we've got now is we've got this low-res piece of geometry inside of Maya. And I talked about how rendering engines, something like V-Ray or RenderMan can take these vector displacement maps and use it at render time to get to that displacement look. Well, now what we have inside of Maya 2013 extension is the ability to use the Dx11 engine inside of Maya. The DirectX 11 integration in Maya 2013 is native. It has an API that exposes everything directly to you, and we've utilized that to make a Dx11 shader plugin. And that's what this character has on it. The thing that's really cool about the Dx11 shader plugin that we supply with the application is it does a couple of really nice things. First of all, it ships with an Obert shader, which is just an HLSL shader that we've developed that has many of the next-gen gaming kind of workflows built into it. So things like tessellation on the GPU, vector displacement maps, which we just painted in Mudbox. We can actually now use with this HLSL shader to displace this character in the viewport. Again, all happening on the GPU. Has a translucence model, an ambient model. It has lots of really kind of next-gen gaming effects in here, and we'll start dialing all those on. Another thing that's really interesting about the shader plugin is it will handle HLSL shaders and bring them in and make them behave as though they're native Maya shaders. So if you have HLSL shaders and you load them through this new shader plugin that we have, it'll actually handle the light binding for you. So what does that mean? Well, that means if we do something like hit our 5 key in our Maya viewport and jump to our shaded view that doesn't have any textures, that HLSL shader that's on that monster basically behaves the same way as the native Maya shaders do in the background. Obviously, if I hit my 6 key, which is use my default lights, the lights attached to the camera, you can see that, again, the HLSL shader is behaving exactly the same way the Maya shaders that are in the rest of the environment are behaving. This goes one step further. If we go ahead and we select the background, I have a little point light floating there in the background, and I say, lighting, use selected lights. As I start to move this light around the scene, you can see that it is actually using what I've had selected. So this light binding is handled automatically for you, and the real magic of this, or the real benefit of this, is it lets you work with HLSL shaders in a very Maya-esque feeling way. So let's just go ahead and get that light back to where it should be, deselect that guy, and obviously we want to hit 7 to get our hardware lighting back on. So this is really cool. Viewport 2.0 has had some really nice speed improvements in the extension also. So things like the screen-based ambient occlusion is faster. I've got the hardware texture multi-pixel filtering turned on. Again, these are things that in 2013, they kind of hit your performance really hard. There's been some great enhancements made to the performance of Viewport 2.0, both in DirectX mode and in OpenGL mode. So it's a couple little things that will make your day a little smoother. So let's go ahead and let's talk about displacement map. So if we want to capture that displacement map, if you remember, when we sculpted that character in Mudbox, we went up in polygon count to 4 million polygons. If I try to displace this character and those are the only vertices that the shader has to work with, it's not going to look very good. So this is why we want to go ahead and turn on the use tessellation. As soon as I turn on the use tessellation, you'll see there's a little bit of change that happens to the look of that character. That's because it's using tessellation on the GPU to smooth this character out. If we look at the wireframe and see the mesh that it's made, it's a much higher poly count. Very, really cool. And that, again, is happening on the GPU. Now that we have those extra vertices in there to work with, we can start to do some cool things like turn on our vector displacement map. So I'm just going to kind of walk down the list here and just add on a few of these effects. So obviously, little rim lighting, we might want to have that to give them a little bit of back bounce light. The ambient model is kind of nice on this shader because we have a breakout for the top as well as the underlighting. So we have sort of a hemisphere that goes over it that's a solid color, and then we can go ahead and give it a little bit of bounce light on the ground plane there. The diffuse map, we'll get to that one in just a second. So let's talk about displacing. The first thing that we want to do is we want to capture that subtle detail using a normal map. And the normal map has the ability to be overdriven, so you can increase the height of that guy. And the next thing that we want to do is we want to actually see some displacement happening here. Those little bumps we want to have bump up, the kind of ripples that we painted on the neck, the belly that kind of overfolded with that vector displacement map. We want to capture that using the displacement map. So if we turn on our use displacement map and we start to increase the value of that, as I start to move that, you can see obviously it's displacing those vertices, it's kind of moving that character, and it's using a tangent-based vector displacement map. So we're going to get that undercut or that fold that we sculpted inside of Mudbox around the belly's waist. So this is something that just wasn't possible before the extension inside of 2013 for Maya, and it's a very powerful tool for doing visualization, for games workflows. There's lots of advantages to having the ability to see these vector displacement maps in the viewport. So let's continue to refine the look and feel of this character a little bit more. If we scroll back up to the top here, you can see that we have some extra attributes that you wouldn't have on like a blend or a Phong for dealing with the diffuse. What I want to do is I want to soften the effect of the skin a little bit. So if we turn on Use Soft Diffuse, really what we're doing is we're kind of pushing the what's in direct illumination and what's in shadow, and we're softening that transition a little bit. If you look right across the arm right here, like where my cursor is moving right now is basically direct illuminated, and then this is obviously not being hit by that directional light. And if we start to push the diffuse value a little bit higher, you can see that it just starts to feather that and blur that. So it gives us this nice, smooth transition of the direct illumination to the shadow, and it really makes the skin look a little bit more realistic. Some other things that we can do that are kind of cool is start to change the specularity model. Let's go down here and turn on a spec map. That's going to break it up a little bit more, but it's still basically using a Phong specularity model, which really isn't that great for skin. So we have the ability to come down here and just throw another switch on that now makes the skin behave exactly the way you'd want it to, or a little bit more realistic. So obviously we get this really nice kind of hot specularity where it's very abrupt glancing angle, and as we kind of spin the character around here, he's got this really nice soft look and feel to him. So the last thing that we want to talk about, I'm going to turn the ambient down a little bit on that guy. He's a little too hot. The last thing that we're going to talk about is the translucence model that this Maya Uber shader has. And again, this is just an FX file, right? You can take the Maya Uber shader, rip it apart, use the code that we've provided with it to add in your own stuff, or maybe build on top of this. It's a compiled version, but we also include the non-compiled version of this HLSL shader. So the next thing we're going to do is talk about translucence. So anyway, we have 3 lights in our scene. So anywhere I get kind of backlit, that's the point light that's hitting them from the back. That's that sort of sunlight coming in here. When we turn that translucence on, I've got it overdriven just so you can really see it, right? So you don't want your character looking like a jelly bean. We'll start to dial this back a little bit. So if I give it a little bit of distortion, that sort of scatters the backlighting as it kind of passes through that character there. Then you can use things like the power to adjust sort of how strong it is and how quickly it drops off. The other thing you can do is you can provide this with a map, just a luminosity map. And if it's white, it's translucence. If it's black, it's not. So I pinned another little translucence map up inside of Mudbox. And I just want to, I kind of overdid the hands. I should maybe turn that back a little bit. But the ears are going to look pretty cool here. So we'll give it a little bit less distortion. We'll let those ears sort of bounce through here. We'll crank the power down on that guy. I might drop the overall down a little bit and maybe give it a little bit of minimum so it just kind of pumps it up. And again, I'm overdriving this just so that you can really see the effect, but without the translucence, with the translucence, so we get that kind of nice backlight happening. So those are a few of the things that are new inside of the Maya viewport for the extension release of Maya. The next thing that we want to talk about is the virtual production aspect of the workflow. So all of this stuff that we've been doing is basically just raising the visual fidelity of your characters, which is really great when you're doing any type of virtual production work. The more information you can give the director as far as the look and the feel of what the end result will look like before you go to render is a good thing. And that's why these viewport improvements keep showing up inside of Maya. You know, we started this agenda for Viewport 2.0 several releases ago, and every single time we come out with a new release of Maya, we're adding more features, more support, and getting really nice speed improvements. The speed improvements for this release are actually pretty substantial. So the next thing that we want to do is quickly talk about virtual production and motion capture. So Maya has the ability to use something called Human IK. Human IK is the underlying technology that Motion Builder is built on. It's been around, you know, it's sort of the foundation of what Motion Builder is. And what Human IK brings to the table is an extremely elegant mechanism for dealing with disproportionately scaled characters. If you're doing motion capture of a human, you're trying to shove it on a lizard, you're going to have all kinds of issues of scale problems. And that's what Human IK gives us, a great tool for dealing with these differences in scale. And it's inside of Maya, and there's been some pretty cool things that have been added to it in the last release that allows us to use Human IK, but push that data onto a traditional animator's rig. Traditional animators aren't always happy about automatic rigs. So we now have the ability in Maya to sort of take the best of both worlds and use Human IK to do what it does really, really great, which is retargeting, and have that information pushed onto a standard custom rig. So let's go ahead and check that out really quickly. We'll hide that monster. We'll turn this girl on. So obviously, this girl's got a series of NURBS curves that have been set up as control systems. So they're just tied into standard IK chains, standard FK down our skeleton. So these are just driving FK. And what we want to do is we want to use that control rig to move this character, but we want to have Human IK kind of take over that control rig and push the motion capture data onto it. So when working with Human IK, the first step of the process is teaching the Human IK solver about the hierarchy of the skeleton. And this is something that's really fast and easy to do. You do it through the characterization process. So we're going to define a new skeleton for Human IK to work with. Let's go ahead and just show our joints. We'll go to a wireframe, X-Wave mode here really quickly, hopefully. You can do it. So what we're going to do is we're just going to map these bones to the bones inside of the viewport here. So it's very fast. Double click on the bone, swipe over it. It'll match the bone. Name mirroring's turned on so it finds both of these. Now I'm going to use a template to accelerate this. You can save your own templates out. We ship with templates for HIK, which is a Human IK solver, as well as for cat and biped coming from Max. Let's go ahead and turn on HIK. I know that's where the skeleton originated from. And you can see that all of those have been filled in, including the hands, some extra bones down the neck, and 3 spine joints. So with that done, we can go ahead and we can lock that character off. We'll get back to our standard view here, and we'll turn on our Create Custom Rig. So we've taught HumanIK about the hierarchy of the skeleton. The next step is teaching HumanIK where to push that information when it's figured out how to solve for this character. And in this example, we want to go on a custom control rig. So we need to teach Maya about that rig. You know, this rig could be anything you want. This window that gets drawn is actually procedurally drawn. It looks to what we've done in our character skeleton definition to figure out what to do. So you'll see that it has 3 spine joints in there because we defined 3 spine joints down our character. This is user customizable. You can put your own icons in the background of it. It's very extensible. So what we're going to do is we're just going to go ahead and we're going to say, you know what, for this hand controller, that guy moves the IK chain as well as the FK for that hand. So what we're going to do is we're going to map that guy to this, and as soon as I do that, it's smart enough to know this controller is going to both try to get information for translation and rotation put to it. If we grab something like a spine joint, which is really just going to get driven by FK, we jump in here, we right mouse click and assign that, you can see that it, again, has enough intelligence to know on this spine joint I should only be hooking up the FK, or the forward rotational values on that joint. So I'm going to accelerate the process of filling this in again using a simple text file that's saved out, a simple XML file, goes through and populates that. So now that we've done that, everything that we need to begin retargeting this character is set up. So let's get some animation data in here really quickly just to show you sort of the basics of how that solver works, and then we'll start using some live data coming from the NaturalPoint stage. So what we're going to do is go ahead and just use our visor to browse to our desktop, or actually to not our desktop, but to a folder inside of Maya that's got some canned data. And this is just great data to use to test a character out. I always just find myself going to these mocap examples and dragging them in here just to go ahead and simply test the movement on a character. It's a really fast, easy way of doing that. So what we've got is we've got our character 1 that's got a custom rig drive in it, and now we're going to tell it what the source is. Really what this is what's going to drag that skinned character around, and any list of characters that have been defined through HumanIK will show up inside of your source list. So for this example, we're just going to grab that mocap and shove it onto our character. So if we look at what's happening here is what the retargeter tries to do, what HumanIK tries to do right off the bat is it tries to match joint angle. So if you look at those arms, it's matching all the FK angles. It tries to match joint angle, and it does an action space compensation. So what that means is if your character has shorter legs, it's going to adjust the amount of translation that character is going to do to make sure that when you're matching joint angle, the feet don't slip, right? So it handles that for you right off the bat, which is great for a lot of situations. But when you're dealing with characters that maybe have really short arms or really big arms, matching joint angle might not be the best choice. Sometimes you want to match world position. So if we scrub through this, you'll see the feet are locked down pretty good, but that girl's hands, because she's got shorter arms, you know, she's not going to reach the ground. So this is where we want to start using HumanIK to start to overcome some of these issues that come up when working with motion capture. So to do that, it's a really simple process. We just go to any of these end markers, and we can just start to reach the translation for that new end marker. So as I start to pull that up, you see that hand. Actually, we'll use this hand here. You see that hand start to try to reach down and grab the ground. If I say match rotation, what's it doing? It's actually going to try to match the orientation of that original hand. But it stops at the body part. So this is the power of HumanIK. With HumanIK, we can say, you know what? Actually, don't just stop at that body part. Have the ability to extend that range all the way through the whole hierarchy of the skeleton to go and reach that world position. So that's amazing. We're doing that with HumanIK. It's kind of black box in the background, using the insolve to figure out how to do the forward kinematics rotations on the spine joint to actually get to that end result. And if we bake this data onto that custom control rig, it's just going to work. So it's really, it's pretty hardcore. This is really cool stuff. Having worked with Motion Builder for many, many years, the ability to actually shove it on a custom rig inside of Maya is it's kind of cool, actually. It makes your day good, for sure. So there we go. You can see that we've got this character, you know, trying to match joint angle, but when it has to get down there and touch the ground, the HumanIK solver fixes all of those problems for us. So the next thing that we're going to do is we want to begin working with this with some real live data inside of Motion Builder. So you saw us do some single-click operations to get data back and forth between Maya and Mudbox. We do the same exact thing when we're working with Motion Builder. We take our actors that are in our scene, and we single-click them over. This time what we're going to do, let me actually just do a 2-up view here of my screen. We can close that guy down really quickly. I think I've got a motion builder queued and waiting. So we've got our motion builder scene here. What I want to do is I want to send this girl over to motion builder. And this is where we cross our fingers, because we are working with beta builds here that have been, they've been doing beta builds and updating the beta builds for me on the fly as we've been going to get this stuff working. So thank you so much to the guys. And
have shaders from the the shaders you've just seen running also in the same system that is already up and running that you guys can use.
Yeah, we put a panic call into Toronto, and they turned us around some special builds really quickly. So thank you to the guys in Toronto that made that happen. So if we click Live Connect, we can take this object that we want to send, or the person we want to send, which is the girl in this example. This is where our fingers are crossed, and it's going to come across and establish that connection. So there shows up the girl. She's in our scene. So if we want to move our kind of monster over here, let's get rid of that stance pose on that guy and just actually, I think this might be a good time to start talking about NaturalPoint, because we can start moving these characters now that they're in the environment with some optical data. All
right, so why don't we, I'm just going to call up Brian here from NaturalPoint and have him talk a little bit about the rig that they've got set up over there and what they do.
Thanks very much. Thanks for coming today. So at OptiTrack, we democratized motion capture. We made it so it was affordable for people. So we've got a couple of new products that we'd like to have you stop by and check out. We have a virtual camera system and a motion capture system for full body performance that starts at about $20,000. So the old $200,000, $300,000, $500,000 systems we've completely turned on its head. It's much more affordable. So today we're going to show you the lovely Noreen and the lovely Wendy, who are our performers. But I got a question for you. When we were planning on doing this this presentation for you guys, it occurred to us that it might be interesting for you guys if you saw Shawn tear off the clothes, show the motion capture suit, and actually be the performer for next year's show. Do we have any show of hands that you'd like to see Shawn in a black suit with reflective markers? Okay, you're off the hook, I think, buddy. Okay. So we're going to show you two products, really. It's the motion capture system that captures the movement of the performers and produces a digital character in real time that you're seeing on the screen. In addition to the virtual camera system that we didn't invent, but we perfected it, and it's an integrated system that goes to work right out of the box. So what you'll see over there is live real-time motion capture, and the guys from Halon, our customers and friends, who are actual directors, not engineers like us, who are going to be doing the art and showing and directing the scene. So thanks for having us, and stop by. Thanks.
Thanks a lot, Brian. Okay, so what we're going to work our way towards here is, you can see this is actually their screen being brought over to us. So you're seeing their characters in their software as it's detecting the motion. We're seeing one camera there, and you can actually see the man with the virtual camera standing there. He's moving around, and you can actually see that camera here in the view. And then we've got the two characters. We're going to stream two characters over here, and you can actually see in this viewport we've already got that happening. We've got the two characters moving and tracking. And then we're also going to stream camera and props over here as well. So we're going to go a couple steps further. So Daryl, how are things going on your side?
Get my mic back on here. So obviously we've got the Maya viewport with all that beautiful quality that Viewport 2.0 brings to the table, showing our talent moving inside of there onto that custom rig. Super duper cool.
So this is a live link between Motion Builder Maya. We're getting data from the booth to Motion Builder, and then Motion Builder is pushing it through to Maya so you can see all the DirectX 11 shader work. So you get the absolute highest quality virtual production look, so that the director actually really gets a feel for what this movie's going to look like.
Yeah, I just turned on depth of field inside of there. So all the nice things that the Viewport 2.0 brings to the table, we can now use when we're visualizing our characters, which is really powerful. We're going to close this down, and we're going to hop into Motion Builder and start talking about a couple of the things that Motion Builder is really great at doing. So obviously we've got two characters coming inside of here, but they have a virtual camera over there also. So let's go ahead and hook that up. I'm going to bring the optical data offline really quickly while we drag in another device. So when working with Motion Builder, we basically have devices that come in, and they're then just become sources that we can use to move our characters around. Just like when we were in Maya, we had a set of sources that we could use to move that HIK system around. Same thing happens here. So we're going to bring this offline really quickly, and we're going to drag in another device. In this case, it's going to be that VCS camera device. So we'll merge that in. We'll bring that VCS camera online. And this takes just a second the first time to initialize. Once that's done, we can go ahead and we can create a camera from that. And it looks like we might need to give it a little nudge there. We'll bring our optical data back online for our characters. And it doesn't look like that camera nudged. Let's go ahead and bring it offline and bring it online one more time. There we go.
There we are.
So now what we have is we've got the virtual camera inside of here. We can go ahead and switch to a 2-up view inside of Motion Builder here, so we can view through the virtual camera on this side. We'll jump over to this panel and we'll view through my working camera over here. So the thing that's really great about Motion Builder 2013 is we've had a lot of production tools put into it recently that have come directly from some of our work with our larger clients, things that are very specific to working on stage. One of those would be something like the new heads-up display that we have. So the heads-up display is really cool because it's all kind of dynamically built on the fly, and you can query any attributes that are inside of Motion Builder to have show up in that heads-up display. The thing that's kind of nice about it is it also has the ability to have flash inside of it. So if you wanted using our scaleform technology, which is something from our game side. So it's really cool when you start to see all these different parts of different kind of industries coming together to make this virtual production workflow a reality. So if, say you had a heads-up display on Iron Man and you wanted to see that through the director's view of the camera so the director could visualize those flash-based graphics, we now have the ability to do that. So what we want to do is we want to look at another one of these production tools that came, specifically out of doing this type of work on the stage that have been added into Motion Builder recently, which is our ability to record data directly to disk. So this is a really cool workflow that's been added to 2013. What we're going to do is we're going to go ahead and we're going to create a couple of tracks in our scene here. We're going to make a generic character track. Well, actually, we'll make 2 character tracks. And we'll put our monster on one, and we'll put our girl on another. We'll name these so that they're going to have something that Shotgun can track. So everything that we're doing here is going to be in the form of metadata. All the stuff that we're writing out in these FBX files that are going to stream into disk will have tokens associated with them that Shotgun can then track. So things like time code, the shot, the name, the take, the date, the camera angle, all that stuff could actually get recorded into the name of these tracks, and Shotgun could pick that information up and use it to really kind of corral that data or that information. Because when you're dealing with virtual production, you're going to be making tons and tons of data, which I'm sure Shawn can talk about while I prep this.
Absolutely. So this is, many people think of what we're doing right now as the kind of the most difficult part of virtual production. In many cases, the most difficult part is wrangling the data that you generate. Because when you really stop to think about a virtual production shoot where, a Spielberg or someone is out there, you might have 6 or 7 actors in mocap suits, you have a couple of virtual cameras, you have the sets itself, and they'll go through it and do like 10 takes. And he's like, all right, this actor and this actor, you nailed it, you can go home. The other 4 actors, I need you to stay here, and we're going to keep having you act against the virtual versions of yourselves because I think we can make better acts. So you do another 10 takes with those, and you keep resolving it down. You've got 50, 60, 70, 100 takes of various characters. Finally get that down. Now the director can just send all the actors home, and now he can spend the rest of the night with the virtual camera looking in the virtual world and trying out different shots and trying to find what the angles will look like. All of these end up being more takes and more versions of data. And on top of that, they can make changes to the set. So where was the box? Where was the table? All that has to be tracked and recorded as well. So this is really the reason we wanted to have Shotgun involved in this particular demonstration, because it is important to be able to track that data and be able to find it again and get the right stuff 6 months later.
All right, so what we've done now is I basically put in a couple character tracks, a generic camera track in there, and we're going to specify where we want this data to be written to. Where are we going to put it? We're going to put it in the Shotgun Watch folder. So it's always going to get shoved into that Shotgun Watch folder. And because I've done this this demo one other time, I know to copy that so I don't have to browse my disk. So we'll go in here and bring this guy up. Where do we want to go? Shotgun Watch. Same thing for the camera. So whatever we put into this Shotgun Watch folder, Shotgun's going to pick up and automatically grab. Another thing that's worth mentioning, again, is if you look at these tracks and you look at the properties for these tracks, there's going to be some naming tokens being recorded out. So simple stuff, name, start date, start time, and we could be pumping out time code. 2013 of Motion Builder has the ability to also export out what we're seeing in our viewer through an SDI card on a Quadro 6000 with time code embedded. So when you're recording this stuff, you might have that Linehouse time code feeding into Motion Builder, the output movie that we're getting is going to have the same stamped time code, and the clips are going to have the same time code. So when you do your select and your edit and you say, go back and refine that data, all that information is going to be embedded into all of this through metadata that Shotgun is going to be tracking. So it's really cool. So we're ready to record a take here. I've got my working camera over here. We've got our director camera over here. This is this would be on the external view that would be getting spit out through that SDI direct into an edit system. And whenever we're ready, we can do some action. Oh, we've got a prop moving too. We can't forget about the prop.
Yes, got the prop.
So this is happening live over there, guys. So everybody that's sitting in our booth, if you look to the left, you'll see the actors, the prop, the camera. It's all happening on the NaturalPoint stage to your right.
And you're seeing it up here as well.
Left for me.
So.
Oh, even better.
So because in the original animation, the character uses a butterfly to entice the monster, and since we're giving away an NVIDIA card here today, we figured this is Land of Geeks, and NVIDIA cards are much more likely to be enticing than a butterfly. So we've got ourselves set up with the NVIDIA card box that's driving the box inside of Motion Builder in Maya. So Brett, how are you doing over there? Do we hear Brett? We need the other...
Hello.
There's Brett.
Hi,
there
Shawn.
we go. So we have Brett, who's going to be acting as our stage director on the other side. He's going to be directing the talent on what they will be doing. So Brett, why don't you go ahead and set the stage for them, and Daryl will be ready for your call when it's time to record.
Okay, great. Thanks, Shawn. Okay, Noreen, so what I want you to do is introduce the butterfly/video card to Wendy, our creature character here. And Wendy, you're just going to be slightly interested and curious. And Daryl, you can go ahead and roll on record on mocap.
Okay, we're rolling.
And action.
Oops. Stop that. I didn't hit the record button. Sorry about that, guys. Let's record another take. So you can see as these takes come in and they're streaming to disk, we get all the naming tokens that we've set up. And if we stop this, and that would have the time code stamped into it also if we were running the line time code, and we go back and do another record, hit the play button again, you can see that we get another clip that's getting written into the story, basically spewed right to disk. And the thing that's great about this is this means you're never going to run out of RAM. If something happens on the stage and you lose power or something, you didn't just lose that one amazing take that the director wanted. It's not just sitting in RAM and it went away when the computer got kicked or something. It's actually on a disk somewhere where you can go back and get it.
All right, let's do one more aggressive take here. Let's make it real action.
Okay, great. So this time, Wendy, you really want to get that video card. That's looking good, and you can grab it. Okay, go ahead and record, Daryl.
All right, we're running.
And action.
All right, and
cut.
Perfect.
All right, so as I mentioned previously, all this information is getting written to disk. The metadata is there, and it's just waiting for something like Shotgun to take over and manage the massive amount of data that we've generated. So we'll hand it over to Ryan, our partner at Shotgun.
Hi, my name is Ryan Maeda, and I'm the product producer for Tank with Shotgun Software. So Tank is a new product, and it's now in beta. It's sort of our take on asset management. It's built on the Shotgun platform. It's engine and app based and sort of lets you design your workflow app by app. So for this case, we put together a little workflow in conjunction with the stuff that the Autodesk guys are showing. So as we discussed, they've been streaming these takes to disk. So over the course of the last 3 days, we've amassed a whole bunch. So the first app that we'll show is just a way to sort of jump in and view the takes using the QuickTime Player plugin. The FBX QuickTime Player plugin. So basically, we've amassed a bunch of takes, and we're just going to go back and check them out and see which one we want to use. So we can, sort of scrub through, check it out. So in this case, we're going to say like, this is a good take. We're going to use that one. So we can mark it as a circle take. And then in Shotgun, you can flip over to another tab like this, and basically you can just see all of the takes that, if you're going through the whole shoot, like all of the takes that you like will be there. So for this example, we're going to also just apply this motion to a layout scene, and then we're going to pass it to our animator, who's going to do some refinements in Maya. Another thing you can do is just pick our layout scene, which is we've got this page that's amassing all our environments. And we can open it in the associated application, which in this case is Motion Builder. Sorry about that. My computer's a little weak. So we're going to open this guy up. So we're going to see this scene. It's ready to go here. Oops. You know, we can pan around, check him out. And we've got a tank menu in Motion Builder. So first thing I'll do is snapshot my file. This is going to be my anim layout.
So what's the snapshot mean when you're snapshotting?
So the snapshot
your file?
is it's sort of like a tank save as that pulls out all of the need for an artist to know like where files are supposed to go or what they're supposed to be named. Just helps keep the file system organized. So the people managing the pipeline just don't have to worry about artists doing the right thing, and artists don't have to think about it. They just focus on the art.
Got it. Cool.
So I'll snapshot my file, save it out, and then I'm going to load my mocap take. So this brings up the loader, and it's filtered down just for the circle takes. So as an artist, I'm just only getting the stuff that I'm supposed to use because we might have like hundreds and hundreds of takes. So I'll pick this guy. We're going to use the monster, and we'll apply him in. So now we've got some motion on here. He's moving around. And I'm going to go ahead and publish this for my animator to pick up. So we got a little screen grab tool so that more images show up in the system. Ready for anim. All right, and now this is ready for the animator to pick up. So I'll flip back over. And so now I'm the animator. This is my homepage in Shotgun. It's telling me what I'm supposed to do. Right now I've got one task. I'm going to do the animation for this shot. So next thing I'll do is just jump into Maya. Maya will come up. So the next thing is that Maya's also got a tank menu. It knows what I'm working on. In this case, animation for shot AA10, and it asked me if I want to open any of my recent work files. But since I'm just starting, I don't have any work files yet. So first thing I'll do, just load in what I'm supposed to get. In this case, I want the garage, and I've got my anim layout, and I can pick this guy up. So that's going to import the scene that we published out of Motion Builder.
So those three columns are different levels of granularity as far as the filtering. Is that what we were seeing?
Yeah, so it's like the asset, and then we have the type of publish, and then we have the actual version that you're going to choose. So by default, it's going to prioritize the newer versions.
Okay.
So now I'm in Maya. I've got the scene in there, and I'm ready to animate.
Perfect. So just to give people kind of an idea of just how far you could go with this, again, when I was talking about the amount of data that gets generated, in one of these scenes, if say you're at Weta or Lightstorm or something like that, there's going to be data for the placement of every coffee cup in the virtual scene, everything for every shot. If they moved a cup over, someone made a note in an asset management system that cup is exactly here. So if they decide that's the take the director wants 3 or 4 months from now, they can rebuild that entire thing virtually exactly the way it was. So in this case, an animator, a modeler, whatever, when they pull up out of the asset management system, that shot, everything is already pre-compiled and put into the system where it's supposed to be for them to get started. They don't have to worry about the mistake of, oh, I grabbed the wrong thing at the wrong time. So this is really why we wanted to have kind of the shotgun side things shown here. But I also want to just, before we wrap up on the presentation, talk about the fact that the technology you're seeing here, other than the few kind of new beta bits, which is specifically around the viewport shader stuff, is all shipping technology. This is stuff people are doing now. In fact, this is all technology that has come out of our partnerships with companies like Weta and Lightstorm, working directly with them on major motion picture productions, figuring out what is it you need, what are the things slowing you down, and that's the type of stuff that we've been dumping into these products over the last couple of years. This is all production-proven, production-tested style technology. We're not just making up a feature and saying, hey, this is what people are going to do. This is stuff that we were told, we need this. This has to work this way. So that is our virtual production demonstration for today. Thank you very much.